Hi, everybody. Welcome back to another episode of Web Development. Let's see where we are and where we might be going. So, for the last several weeks, we've been discussing how to build web applications, first focusing on creating the client application, and then the second half, we'll be focusing on the server application. And in that part of the client application, we'll be focusing on implementing the user interface built on top of HTML and JavaScript and CSS. Mostly we've been focusing on just the look and feel, laying out content with HTML, how to lay out things and format it as lists, headers, paragraphs, tables, and whatnot, right? And then coming back a little later to make it look a little more presentable using CSS and Bootstrap. Also with Bootstrap, we were able to address various screen sizes as users either use a very wide screen or smaller screens on tablets, phones, or larger computers, larger monitors. We can configure our content to adapt to the various screen sizes. Now, but up to this point, all this content has been static, right? So we've been copying and pasting a lot of content, right? For instance, when we render multiple courses. Right now, the only way that we can do that is by copying and pasting manually that content. So what we're going to be learning about from now on is using programmatic, functional programs, right, to be able to compute what the user interface should be based on data structures, databases, also user events, right? As users interact with the application, they modify the data. They modify arrays and objects. They add objects, modify objects, delete objects, and as those changes happen, right? As these data structures change over time, right? The user interface needs to be able to show those changes and give feedback to the user that those changes are taking effect. So today we're going to start talking about how to use JavaScript, right, as a functional programming language, right, to compute the user interface in the on the client side. Okay, so we're going to introduce how to create data structures, how to create functions, how to pass data around, right, and how all that pertains to rendering a user interface. Right. In the end, the point of React.js is to be able, basically a function that converts a data structure and converts user events, combines those things, data structures plus user events, combines that and computes what should the screen render, what should be displayed on the screen. And you write that function. It's basically writing a function that is made up of many different functions that use if statements and branching and looping, right, and data structures and user events, right, to compute, right, to calculate what should the user interface look like, based on all that information. Okay. So also today we're going to introduce the third assignment. The assignment two is due later tonight. Uh, and so today we're going to do the third assignment. Get started with the lab section, right? We'll start practicing on various skills, right, that we need to learn on how to use JavaScript and functional programming, right, to compute a user interface. Also, this week, right, the third quiz will be available. Again, you have a whole week to take a look at it. Online classes. You can choose when to take it, right? And they're all about 20 minutes long, but you get to choose when that happens. And what else? Yeah, so that's the point. Also, today at the end of the lecture, I'd like to go over the requirements for the project. There are two options that you can take, right? And one of them is pretty open-ended. And so we'll discuss that towards the end of the lecture. Also, after the lecture, if you want to stick around, I'll have office hours. If you have any need of, if you need help either deploying your assignment or you have any questions on completing the assignment that's due today, right? Then stick around, and I'll be able to help you one-on-one. Okay. Any questions so far? All right. Okay. All right. So let's talk about JavaScript. All right. So JavaScript is a programming language, and it's mostly used or most famous for being the programming language of the web. Right. It's been around since very early on when Tim Berners-Lee came up with the World Wide Web, and Netscape started to look for ways to compute the user interface, right, and in the browser, right, to be able to run code inside of the browser and be able to manipulate the user interface, right, programmatically. And at first it was folks got to push back on this idea, right, that this executable JavaScript was going to be downloaded from another machine, right? And then it would execute in your local browser. And folks were concerned about this, right? And some folks would disable JavaScript on their browsers. But since then, the language has evolved quite a bit in browsers as well to address some of those security concerns. So, for instance, any code that executes in your browser, it does it within a sandbox, right? That it cannot exit the sandbox, this security software sandbox that doesn't allow it to access the file system, doesn't has limited access to the network, right? But mostly it cannot go through any of your private information. So the way it was envisioned is that you would there was introduce a new type of element called a script element, where you can embed inside executable code, right? That would be a script using a script language, JavaScript, that would be executed by the browser, and then the browser would be able to interact with the user. So here's an example, a trivial example where we are popping up an alert box, right? That says hello world. So you have an opening script tag and you have a closing script tag, right? And in there you would have your code. So let's go through some of the syntax of JavaScript. This is all very low-level JavaScript, and that it's very rare that you would actually write a low-level JavaScript, but nevertheless, it's always important to know where things come from, right, and what the browsers actually understand. Now we are going to be coding in React, right, and React doesn't use this low-level JavaScript, right? Although you still have access to it, we don't directly use it. Instead, we rely on compilers, right, that convert React.js. Let me move this slide around. Maybe it's better up here. So we using React.js, we're up here, right? We write our code using this more modern version of JavaScript called TypeScript, right? Now, this is a language that is not understood by browsers. Browsers only really understand is JavaScript over here, component.js. So we use React to interpret that TypeScript, right, to compile it down to and convert it into a version of JavaScript that browsers do understand, right? And so it's not really it's not a compiler. It's converting between two versions of scripting languages, right? One is a higher level, right, that allows you to do imports, right? Do things that the JavaScript language doesn't support. Well, ES6 does. But browsers, only understand very, a more less sophisticated version of JavaScript. It is converted into a version of JavaScript that is understood by most browsers, right? And so that it's a very verbose. No, it doesn't have any of the great features that you would find in TypeScript. Also, the TypeScript version that we're using is a version that can be mixed in with XML or, in our case, HTML. So definitely, it's not a version of any programming language that browsers understand. So React does the conversion of this high-level modular component-based programming into a much lower-level version of that, which gets loaded or linked in from an index file, an HTML index file, that is what the browser actually renders. So the browser really cares about an index file that loads your JavaScript. But we are way up here, right? That is we're converting through this several layers of abstraction into a lower level version representation of the same code, right? But it's understandable by browsers. So let's focus our attention at this lower level JavaScript, right? And this will be more or less the only time where we will have a chance to talk about low level JavaScript and then never again, right? But nevertheless, it's for, if not for just historical purposes, it's important to understand what's happening behind the curtains. Right. So we have let's go through some of the more common mechanisms of using plain JavaScript. Here we have a function alert that allows you to pop up a dialog, for a user to interact with, or you have console log that allows you to write, to the console of the browser for debugging purposes and things like that. And now this is still accessible. We still could use this, within just regular TypeScript, right? But before TypeScript, one of the ways that we could create dynamic content programmatically is to use the document object. So document object is it's a global object that is available within the browser executable that gives you access to the document object model. Right? So when you inspect a web page, right, this data structure here, this is the DOM, which is used to represent and draw stuff on the screen. Okay, and so browsers give you access to this data structure so that you can delete from the data structure, create elements in this data structure, right? And as you write and create these pieces of content, you are basically writing to the screen, right? So document is a representation, a reference, right, into this data structure, and it has a whole bunch of functions, right, or it has an API, right, a family of functions that allow you to manipulate this data structure. So for instance, the write function allows you to add new elements to this data structure. Right? You can write plain text, right, or you can write formatted HTML, right, a header, a paragraph, okay, which we'll see in a minute. And so when you write this, right, you are adding content to the DOM. Okay, so whenever you see that any of these components that are drawing stuff on the screen using React.js, behind the scenes, this is actually what's happening, right? We are writing stuff to the DOM, right? Also, not only can you write to the document, but you can also read from the document. Right? You can retrieve information from the data structure. Right? So, for instance, if there are elements in the data structure in the DOM that have a particular prime ID, a unique identifier, you can tell the DOM, hey, go and look up, traverse the data structure and look for an element whose primary key is hello. Right? and then this gives you a reference to that element when it's found. So it does breadth first search, right, in this hierarchical tree looking for this element. When it finds it, it gives you a reference. Once you have a reference, you can then manipulate that element that comes back. For instance, one of the things that you could do is to write into it, right, other new content. Right, it might have already content, but you can overwrite it. Right, you can read it. Right? You can edit it. Here, for instance, we are editing the inner HTML. Right, so we are inserting new content, by assigning it, to this inner HTML. Here we're saying, plain text like hello world, but it could be HTML as well. You can format this as a paragraph, right? And then this would be formatted as a paragraph. Okay. So here's an example of an element whose ID is hello, right? And then from JavaScript, we can retrieve that element by its primary key. And then once you have a reference to it, you can assign it to a local variable, right, and then manipulate it. So the element right now references that header, right, and then you can use code to then do additional manipulations on that element. For instance, you can use now the element as a reference to change the look and feel. For instance, there's a property inside of the element called the style property or attribute, right, that allows you to then change all sorts of CSS styling. For instance, you can change the foreground color, you can change the font size, right? And notice that these names, look, they are JavaScript names. See that? They are the properties that you would expect when we are manipulating CSS using the style attribute in TypeScript, right? Which is camel cased. Right? And you can hide stuff or you can show stuff, right? You changing the display, none, or block. Okay. Also, you have all sorts of new data structures, right? Other than just plain old strings, you have dates, right? And these data structures in dates allow you to retrieve the month, the year, the day, right? Weeks, and so on and so forth. You also have data structures such as arrays, right? That allow you to collect elements of the same data type, or even diverse data type. Here we have an array of only numbers, but as JavaScript is untyped, you can mix and match. Not in TypeScript. TypeScript does want you to be a little more rigorous about the data types in an array. Here is we're just displaying the array right on the screen. Here's just an example of how you would go about rendering dynamic content. So for instance, if you have that array of scores, right, you can iterate over it, right, using a loop, and maybe calculate the total and then calculate the average. And then you can use document write, right, to write to the screen, right, that the total is some total here and the average is some computed value, right? Or even better, right, you can create more complex representations in the user interface where you can create formatted content, like write an opening UL, right, with always remembering to close that UL, right, and then use for instance LI, right, to display the various scores. You can say scores sub 0, sub 1, sub 2, and so forth, right, and then display the actual score and then close the LI. So here's an example of computing the user interface, right, what's being rendered on the screen using an algorithm, right, based on some data structure. The data structure here being a simple array, right, and then some function that has an algorithm that renders this data structure, converts it into an equivalent list. Okay. So here's an alternative way to render the same data. Right? So the first one was using a list, whereas in this one, right, we're using a table. So we're opening a table. As we iterate over the scores, we open up a row, right, and then create a column that allows us to various columns that allows us to display the scores and the actual values, and then we're accumulating these strings, right, that represents columns and rows, and then appending them to have one long string that is formatted using HTML that then gets written to the DOM, right, and then it would render as a table, right. Also, we are going to introduce the capability of being able to not only generate and calculate content, but also consume events, right? As users interact with the user interface, they can type, right? They can click, they can drag stuff around, and so we need to be able to be notified when these events occur. So, for instance, JavaScript declares attributes or properties that allow you to associate various events with some event handler. So here we have the onClick attribute, meaning if anybody actually clicks on the button, it will invoke this function, right? And so here's a function, say hello, which is just alerting hello, right? And then you would click on it, right? And so other noteworthy aspects is that typically the script tag, the proper place to put script tags in raw HTML documents is in the head, right? So remember that an HTML document has a head at the top, then has a body. Those are the only two sibling elements. Well, the scripts actually go in the head. That's where they go, right? And nevertheless, you'll find very often that developers will put the scripts at the end of the body, right? So here, for instance, instead of being in the head where they belong syntactically, the browser also allows you to put it, at the end of, well, anywhere really, but in particular at the end of the body. And the reason for this is that oftentimes, these scripts might be too long, too big, and if they are towards the top of the DOM of the document, they will load before any content gets drawn on the screen. So this is the content that gets drawn on the screen, and so if these scripts are big, right? You might spend a half a second or a second, downloading this, and if you have not only just one script, but you might have many libraries that you're downloading, it might slow down the time that it takes you to draw something on the screen. So a good practice is to always put it at the bottom, right? So that you're sure that you're going to pump out as much content as possible, as quickly as possible. Put something in front of the user, to capture their attention, and then slowly load the rest of the content. So here's an example of using inner HTML to be able to update the content of the DOM, right, where we're retrieving some element from the screen, right, and then we are updating that content. So for instance, here in the HTML, we just have a header, simple math, 2 + 2 is equal, and then put a placeholder that's empty with no result, but then use JavaScript to come back, right, and then calculate the values and update the elements, right, and we'll display on the screen. Right, so other things that we'll learn today, with JavaScript is being able to read content that the user generates, right, as they fill forms, and click select element options from a drop down, and then and they fill out a form and they submit it. Is that we need to be able to read the elements from these form elements, right? So we can give those form elements some unique identifiers, which we can then retrieve, right? Once we have a reference to it, we can read the value of that element. Here we're just alerting it. So here's a really trivial calculator, right? Where we have a header, a couple of input fields, where we're going to type the values of A and B, right? And then we're going to display the value of the result in C. And then here we have a button that, if you click on the button, it will add A + B. Okay. So here's a function, a plus b. It will first get a hold of the value in element whose ID is a and also b. Right. Now these are always strings, right? Elements in a or anything you type on an input field, right? They will be strings. So we need to convert them, especially if we want to treat them numerically. We need to convert them into integers or floating point or doubles or whatever. Once we have those values, we can then calculate the arithmetic addition of a plus b and then display in the span, the C span, right? Display the value of the addition. Right. So we've talked about simple primitive data types, integers, right, strings, whatnot. We've also talked about arrays, to be able to collect multiple values. We also have objects, right? And so in JavaScript, we call them JSON, right? That it's a notation that is specific to this language that has the syntax of having opening and closing curly brackets, and then properties in those curly brackets with their respective values. Right? So, for instance, we might declare a variable here or a constant house that has 3 rooms, 3 baths, right, and 1,300 square feet. Right? And then once you declare these variables, you can use, for instance, dot notation, right, to be able to retrieve the values that you put in the object. So if you put this house here, then house.rooms, you can display that. You can say localhost, right, house.room, and it'll display 3. This is an example of retrieving that, right, and maybe displaying it in the in a UL. We can read the data structure, get a hold of the elements by their IDs, and then fill them in dynamically, right, using the dot notation. So get a hold of the elements by their ID, right, and then we're going to update the values with house.rooms, right, house.baths, right, and so we are updating those all on the fly. Okay. All right. All right. So let's practice a little bit, right, writing some JavaScript. Right. Obviously, we are already using TypeScript, right, but mostly the code that we've been writing is just focusing on the HTML side. So now, starting today and for the rest of the semester, right, we're going to focus more on, writing algorithm, using JavaScript to write algorithms, functions, right, reusable modules, parameterizable data types, but in the context of drawing things on the screen. In the second half, we'll still be using JavaScript, but for being able to retrieve data either from a file system or a database. So let's talk about the labs. Okay, so first of all, let's create a lab 3 component or screen where we can do our work. Let's see, under labs, we have lab 1, lab 2. Let's create a new one. Let's copy that. And let's create a placeholder for index.tsx. There we go. And then let's load the labs so that we can add this new lab 3. Okay, so it looks like we already have a placeholder for lab 3. All right, so right now it's just hard-coded lab 3. Okay, so let's fix that. And so let's load the real lab 3 component that we just wrote. So lab 3. Okay, and then in lab 3, we're gonna be working through several exercises. Okay, and we wrote it. We already had the lab 3 in our routes. Oh, also notice that the route, I'm going to add a star here because actually lab 3 is going to have its own routing. So let's add a star in there. Perfect. Okay. All right. Right. Any questions so far? All right. All right. So let's talk about working with variables in JavaScript. Right. So JavaScript has evolved over time. Right, has gone through several revisions, and there are some modifiers, some types of variables that have been around, since the inception of the language, right? And var has been typically, historically, the way to declare variables. And but there, in the latest revision in 2015, there were several versions of new types of variables, right? That are much better than the legacy var, right? And so var has kind of fallen out of favor, and instead we are going to be sticking to these two new ways of declaring variables and constants. To declare a variable, right, that's going to change over time, we're going to use the keyword let. Whereas, if something is going to be constant, it's not going to change, then we use const. But we're going to stay away from var, right? You'll still find it in maybe documentation that's a little bit older, right? And so, but nevertheless, stay away from it. Also, other types that we're going to be using is the JavaScript object notation, right? That allows you to declare variables or constants, right? Identifiers that using the curly bracket can define a hierarchy of properties and values, right? So for instance, here you have the opening and closing of the curly bracket. And then in there we have properties, an object property, a number array property, and an object array property, right? And each one in turn, right, an object property is in itself another object in there that has some properties that are arrays. For instance, this is another array property, and this is another object property. And then finally, you have actual data, right? You have, for instance, another object property is an object that has properties Q and W with values 111 and 222, right? Or a number array property that has numeric values 1, 2, and 3. Okay, and you can use dot notation to be able to navigate through these data structures, starting at the home object being the root, right, and using dot notation to go into each one of the properties. Here, we're retrieving the second array, right, of another array property inside of an object property. So this one right here, second one, 0, 1, 2, that one 5, 4, 3. So there it is, 5, 4, 3. So object notation, JavaScript object notation, we're going to be using that quite often throughout the semester. Right, as I mentioned earlier, right, there has been some iterations in the languages, in particular, going from ES5 to ES6 in 2015. It's been a while. It was 9 years. And but it is important to point out, since there are still some legacy code that's still out there, right, that it's important to be able to read it. Why was it like that, and how the current version is so much better. So for instance, before we would use variables, var, whereas today we use let or const. Right? And for instance, before you could not use declare variables inside of your for loops, whereas today you can. For instance, you can declare I inside of the for loop, very much like modern languages, right? And also today, these variables, you can declare them inside of a code block, and then they would lose any meaning outside of that code block, right? So it's scoped to that particular code block, which is very good. All right, so let's take a look at some examples, exercises to practice variables in JavaScript, right? So the labs are going to ask you to create several of these components, right, and then include them in the labs index file. So let's do that. Let's create here in lab 3. Let's create a few of these, just to practice, constants and variables, and it'll give us a chance to discuss, the this topic. All right, so we have that, and let me just include it in lab 3 so we can follow along. So this is variables and constants. There we go. There we go. And let me close that. So basically, variables and constants is just something simple that allows us to we're declaring all three, var, let, and const. So var is still supported, for backwards compatibility, but we should stop using it. Instead, use let and const. One of the weird things about using variables is that you could use a variable that hasn't been declared and then declare it later, right? And so that creates all sorts of problems. And whereas the new keyword let doesn't do that, doesn't allow you to do that, right? You have to first declare it before you use it. And so here we are declaring this variable, this let, right? And then we're computing some simple arithmetic here. Just to point out the fact that when you want to display the values, right, in your HTML snippet, right, you use the curly brackets, right, as an escape sequence, right, to be able to embed a variable. Right. So notice that if I this over here, right, is being rendered as function scoped 2, right? So this is function scope 2, right? So this here is being replaced. Oops. This here is being replaced by the actual value 2, right? Notice that if I don't have the curly brackets, then this would be literally the text, function scoped. But if I put curly brackets, then this is understood as being a variable, right, an expression that needs to be evaluated, and then the equivalent is a string, right, is then replaced and rendered onto the screen. Make sense? Same thing like any calculated value, or this could be a function, a function call. Okay. All right. Let's go on next. All right, we did that already. Okay, so variable types. There's a quick overview. The fact that we have multiple data types. So export default function variable type. Oh, actually, I have the code here. Let me copy that. So here we have a number, right? Floating point, string. Now, by default, JavaScript or TypeScript in this case, right, is JavaScript is a untyped language, and actually that's not that untyped, but it's that you don't have to declare the types. Right? The types of the variables are declared at runtime. Right? So when this runs, right, it will know, right, that this is an integer, right, because it's being assigned to an integer. It will know that this is a floating point because it's being assigned to a floating point. This is a string, boolean, blah blah blah, all these, right? And for the most part, it works fine. The problem is that when you assign a variable to another variable, right, and then different variables are of different types. You also can query a variable to ask it what type is it, right? And so for using the operator type of, right? So this returns a string, right, that telling you whether this is a number, string, or boolean. So here what we're doing here is that we are then rendering the values. Number variable is 1, 2, 3, 1, 2, 3, 4 strings and whatnot. But I did want to point out this over here. Notice that the boolean, right? We could have says, well, for all the other ones, we were just doing just plain old curly bracket here. But here we took care to concatenate it with an empty string, right? And the reason is that boolean variables, right? They are not rendered. They don't modify the DOM themselves, right? They have no representation, unless what we're doing here is that we are forcing it to be converted into another data type, a string. And then you would see true, false, the value true or false, right? But notice that true is not the string true, and false is not the string false, right? Only when we are coerce it into a string, then it becomes an actual string, right? And that will become very important a little later when we look at if statements and Booleans, right? And all sorts of Boolean related expressions, right? So let me import this into the lab 3. So variable types. Okay, there we go. So notice that indeed the Boolean is rendering as true, right? But notice that if I remove the string here and just save like that, notice that it doesn't render. See that? And that's actually very important that it doesn't render, right? And we'll see why in a minute. Right, so, but here I do want you to see it, that it is the value true, okay? Also notice that is number, right, gets a string representation of whether it's the actual type. This evaluates the type either as a string, number, string, or Boolean, or object, or function, okay? All right, let's take a look at another example, Boolean variables. Okay, let's see, Boolean variables. Let's create that. That's this file, so we can play around with Boolean values. And okay, so this does not have the export here. So export default function, right? And then let's close this here. Very good. And let's import this into lab 3 so you can see what this does. Boolean variables. There we go. Okay, so what does it do? Okay, so it's just displaying a whole bunch of Boolean variables and their actual values. And this is so that we can introduce a few things. Here we are declaring 2 numeric values, right, and a couple of Boolean values, right? True 1 is equal to true, false 1 is equal to false. And then here we're introducing the AND operator, the Boolean AND operator. So true and false gives you false, right? So that's correct. And then here we're introducing the Boolean OR operator, right? That, true or false gives you true. Very good. And then we have the not operator, right? So not false is true. Okay. Then here we're also introducing the triple equal sign, right? As opposed to the double equal sign. Okay. We have the single equal, we have the double equal, and the triple equal. The single equal is used for assignment. The double equal has fallen out of favor, right? But still valid. We still can use it, right? And so we can say we can use another one. True 6, right? Let's call it false. False 3. And we'll say, oh, we have false 3 already. So false 4. And we'll say that 2, 3, 4, is it equal to 1, 2, 3? Right. Notice that it's complaining. Right. Notice that it's complaining the double equal. All right. And obviously this is not it's not equal, and it's already telling us that we can't compare it. Right. So let's use number variable. And let's do 2, 3, 4, so that we get a false. Okay, here we go. So we're checking to see whether 1, 2, 3 is equal to 2, 3, 4. But notice that we're using a double equal as opposed to a triple equal. See that? Right? And let's actually print it out. Let's print it out. So we'll print it, let's see, true 4. Here we'll display it right before, false 4. There we go, like that, false 4. Notice that it returns as false. So the question is, well, why are we using double equal as opposed to triple equal, right? They both work just fine, right? Now, the reason is that the double equal, right, allows you to, it allows you to compare things that are not of the same type. Here, number variable is integer, and this is an integer. And it makes sense to compare integers and integers. But notice that the double equal would allow me to also compare it against a character. Now, this is my IDE, warning me of this, right? But the JavaScript language would be perfectly fine with a double equal, right? Comparing characters, right, and numbers. And then what the double equal would do is that it would coerce one of the sides to the other, right? To try to convert the one of the sides to, for instance, an integer, right? Try to parse it and convert it into an integer, and then do the comparison. Okay. Now that leads to very weird results, right? Unexpected results, and it's very buggy, right? It's very hard to find the case where you are comparing things that are not comparable, right? So folks have abandoned the use of the double equal, right? Since yes, it works when you know that things are the correct data type, the same data type, but you could inadvertently assign it, right? And also IDEs today will catch this, right, and will warn you like it did here. We no longer use the double equal, right? Because again, it could introduce these buggy things, these buggy errors that are hard to find. So instead, we prefer to use the triple equal. What the triple equal does is that it first confirms that both sides are the same data type. If they're not of the same data type, it won't even bother to compare them, where it will evaluate to false. Okay, so as a good practice, don't use the double equal. I mean, your IDE won't let you, and also React.js won't let you. But if you are ever writing just simple JavaScript, just don't use the double equal. Use the triple equal. Here we have the not equal. Again, with the double equal, there is a version without the double equal, right? Which works also as well, but that has the same flaw, right? That allows you to compare things of different data types. Whereas with a double equal like this, then it first checks the data type. Okay. Also, you have the various greater than, less than, right? Greater than or equal. All those are still available, right? And so this is just to introduce the various comparison and Boolean operators. Okay. All right. Let's go on. Let's talk about conditionals. Actually, no. Let me talk about the ternary operator. Let me create a file for this. Oops. Ternary. There we go. And we'll need a file. So export full ternary operator, return. Oh, wait a minute. Paste this. Okay. All right. What am I missing? Oh, yeah. Okay. All right. So let me show you this. Let's import this over here. So this is a ternary operation. Wait, is that what I called it? Ternary ternary. Oh, ternary operator. There we go. Okay, let me display here. Okay, welcome, logged in, right? So let's take a look at this. Okay, so notice, right, that here we have a Boolean variable saying logged in, true or false or whatnot, right? And notice here we have logged in, and notice this expression right here, right? So this expression, notice that it has a question mark, which is basically evaluating the left-hand side, on whether this evaluates to true or false. Right now, this is a simple Boolean variable, but it could be a very complex expression with ands and ors and nots and parentheses and whatnot. Just a Boolean expression calculating whether this is true or false. Then this right decides on whether it is true or false, and depending on that value, this whole expression will either evaluate to two options. One option and then the other option. And those two options are separated by a colon. right? Let's see if I can make this read a little better. No. So if this is true, right, then this whole thing evaluates to the first expression over here. Now, if this is false, then this whole thing evaluates to the second expression here, right, separated by the colon. Now, because logged in is true, right, this is true, then that means that this whole thing evaluates to a paragraph that says welcome. There it is, see that? Now, if this is false, right, notice that this renders as please log in, see that? Right. So again, here you can create complex user interfaces, right? That either render one way or another. Now, here we are just displaying simple paragraphs, but this could be either a another component, right? That it's implemented in a separate file, right? That you've imported over here, and then you either display that or display the other. Okay, and again, this expression can be arbitrarily complex. Okay, so yeah, ternary, very important. So that allows us to do all sorts of very interesting user interfaces. And yeah, okay. So here, there's a conditional here. I'm gonna put it in the same place. I'm gonna copy that. Yeah. So this right here. So let me have. Do we have true? Okay. So notice that we have true here. Let me copy that. And let me paste that in there. Okay. And let me have the if else here. I'm gonna copy this over here. Let me show you this. Okay. Okay, so notice that here we have the if else header here. And notice that this expression is a Boolean expression. See that? Notice the and in between here. So you have the left-hand side, which is clearly a Boolean variable, right, that has been initialized to be true. So this true is being ANDed with something that is not a Boolean expression. See that? What's happening here is that when we combine, right, this Boolean expression between something that is Boolean and something that is not Boolean, what happens is that this evaluates to either an empty content or the actual content that you have here on the right-hand side, based on whether this is true or false. So if this is true, this whole thing evaluates to the paragraph. If this is false, then this doesn't evaluate. It doesn't show at all. So notice that it's showing true 1 here, right? But if we say false, notice that it disappears. It's gone. Not there anymore. And that's why this is achieved by the fact that this the Boolean variable is not rendered. It doesn't. This is where I mentioned earlier, right, that the importance that Boolean expression or Boolean variables, right, don't actually get rendered on the screen, right? That you would have to force it by concatenating by something, right? So that you coerce it into that other data type. Here, basically, the whole thing is being coerced into a HTML code snippet, right, that evaluates to that, right? Or it doesn't evaluate to anything. So depending on whether this is true or false, you render the right-hand side, right? And this is going to be, a very important strategy that we're going to be using throughout the semester, right, to either show something or not. Right? Later on, we'll be able to control this Boolean expression by, perhaps clicking a button, so that would allow you to toggle this content, right, maybe represented as a separate component, right, or some embedded snippet in here, right? And by toggling this true false, right, we can hide and show this content on the right. Okay, very important feature. Okay. All right, so here we have another of taking a look at conditional output. So let me copy that. Also, this is going to allow us to introduce a new syntax for declaring our components that we haven't seen before. Okay. Right, notice the change in syntax here. Right, notice that here I'm declaring a constant, and it's being assigned something that we haven't seen so far. Right, so basically on the right hand side is a function declaration. Here we're declaring a function, and that function gets instantiated. An instance of that function gets instantiated, and it's being assigned. See that? It's being assigned to this constant. So this constant now is not of type integer or boolean or string, is of type function. Right? So this constant now is of type function, which can be invoked. Right? Just like integers can be added, right? And booleans can be anded or not or ored, right? And strings can be concatenated. Well, a constant of type function can be invoked, right? And that's exactly what we're going to do. So basically on the right-hand side is we're introducing a new syntax for declaring functions. It's called the arrow function syntax, okay? Because of this arrow here, right? And so this new syntax, we'll see in a minute with much more detail, but it's a much more compact syntax, right? That is going to have, it has quite a few new features, right? That are really, really exciting. So we'll come back to that in a minute. But basically, we are declaring a function, just like we've been declaring all these other functions. This is the older function declaration syntax. This is a new syntax for declaring functions, okay? And with a whole bunch of new features. All right. So here we're just declaring a function, and we are exporting it. Okay? So in this function, we're declaring a constant called logged in, and based on that value, right? Remember, we have a return here. That when we have a function, usually it's the last thing that function does, right? And it returns a code snippet or that contains some HTML. Now here, notice that we have two returns, right? So this function evaluates to either, right? If this is true, then it evaluates to this return. Otherwise, it returns this, right? So the whole thing is actually rendering something. It's either rendering one or the other. Okay. I guess you don't need this else, right? We could have dispensed with the else and just do that. We could have done that. If it's logged in, we do this and we return, and that's it. Or otherwise, we return that, right? But it looks more elegant like that. So let's import our new conditional output if else. So here, conditional output if else. So it says welcome if else. There it is. Welcome. This says welcome if else. But because it's true, since it's true, it's returning this over here. But if this would be false, then it would render please log in if else, right? It's returning this over here. Please log in if else right here. Okay. Yeah. So you can have multiple returns, right? And the whole component gets evaluated based on some algorithm, some logic, right? Now an alternative way to implement the same thing, let me show you, is to use an inline syntax. Right? So for instance, let's create here the same thing called conditional output, but the inline version. Right? So let's copy that in there, right, and import that into our lab3. Conditional output inline, like that. And there it is. So this is the inline version. Okay, and notice what's happening here is that here we are using the AND operator, right? We're ANDing it with this Boolean variable that it's either true or false. So since we're using two different versions of this, right, where you can either one of them or the other is true, right, because here we're using logged in and then here we're using not logged in. So that means that only one of these two options will render, right? If this is false, then this does not render, right? This does not render because it's false. but not false, this is true. That means it renders please log in inline. If I turn this into true, right, then it renders the first one, welcome inline, because this is true and this is not true. Okay. So yeah, two ways of doing the same thing, right? This is a little more compact, perhaps a little more easier to read, right, where you have a single return and the logic on determining what to render is embedded inside of the return, as opposed to here, the logic what to return is outside of the HTML, right, is part of the JavaScript, okay? Let's talk about functions, JavaScript functions. Right, so arrow functions is a new syntax, right, that was introduced in ES6. There's the language JavaScript, the official name is ECMAScript, not JavaScript. In 2015, there was a huge new version that came out that introduced a lot of new syntax. In particular, introduced this new syntax called the arrow function. Right. So here we have the older legacy function syntax, which is still widely used. Right. We have been using it quite a bit, but you can now use this alternative syntax where you declare a constant and then you assign it a declaration of a function. Okay, and so same thing where here we have arguments A and B, right? And here we have console. So the body is the same. The body is the same, right? But the syntax is a little bit different here. We don't have a keyword function. Instead, the keyword function is replaced by an arrow function in between the parameter lists, right, and the body of the function. Right? We have this arrow that tells us this is a function. So one of the great things about this new syntax is that it's much more compact. So for instance, here we have, for instance, the fact that if the return, right, if you function in the body of your function, you only have a return, then that return keyword is optional. Right? You don't really need it. So for instance, here's a more pronounced version where, so if you have this add E6 ES6, if the only thing you have here is a return, then you can drop the return, you can drop the curly brackets, right, and just replace it with the expression, right, and that's what's going to be evaluated, and that the whole thing evaluates to that value, it returns that value, right. So here's another couple of examples of using the return as being optional, right? So return, we're dropping return the curly brackets, right? But also, right, if you only have one argument, one parameter, even the brackets, the parentheses are also optional. Now, your IDE won't let you; they will force you to put the parentheses in there, but officially, the parentheses are optional. Another thing that also it was pretty big when this new version came out is that now the keyword this behaves as intended, right? The keyword this was not behaving like it behaved in all other languages. It had its own particular idiosyncrasies, and it's not worth even going into it. Now that this keyword behaves, if you use the arrow function, if you use the new arrow function, the keyword this behaves as expected. Other things that are also were introduced in the syntax is that the parameters, now you can give it default values, right? So that if they are not provided when you call the function, then the variables that for which you didn't provide values, right, take on the default values here. Okay. All right, let's talk about, let's create a few labs here. Let's first look at legacy functions, how it used to be. All right, so let's create here a component legacy function. And let's use the old syntax. So here we have a component, a legacy function, right, that is calling on the function's add that is declared outside that takes two values, A and B. Also notice here we have a declaration of the parameters data types number, right? That is now mandatory, right? Because we're using TypeScript. Otherwise, we were using just plain old JavaScript. Calling a function did not require you to declare the data types of that function. But now with TypeScript, thank God, right? We have to declare those data types. So here we're calling it with 2, 4, so that becomes 2 plus 4, 6. Right? We're printing it out, but then we're also embedding it, right? The variable that has been or the constant has been pre-calculated, but also calling that function, right, from within the nested snippet of code, right? So let's embed this in our index, right? So this is a legacy function. So here, legacy function, and there it is. So 2 plus 4, 6, or this one, we are invoking it embedded inside of an escape sequence, right? And this expression is being evaluated to whatever 2 plus 4 is, and that comes back to 6, and that's what gets rendered here, right? So this doesn't need to be just a variable, but it can also be a function call, okay? And let's take a look at the arrow function. So we're going to do an equivalent implementation, but instead of using add, we'll use maybe subtract or something else, right? So let's grab that. There we go. So yeah, notice that here we're using the add, we're using the function keyword to declare the add as a function, whereas here we're declaring the subtract function, right? But using the new arrow syntax, okay? And you can use the function just like you would in the legacy syntax. You can just call, just add 2, 4. Here we're just saying subtract 3, 1. So the invocation of the function syntax is just the same, right? And we're just displaying, and then we're invoking the function from within a escape sequence, right? So let's import this here. So this will be arrow function. So arrow functions. There we go. There. So new, you have 6 arrow functions. 3 minus 1, and subtract 3 minus 1 is 2. Okay. And then here we have an example, right, of using implied returns. So let's take a look at here. Create an implied return. We have to create the export default implied return. There we go. And close that. Okay. So what we have here is that we're declaring this multiply function using the arrow function, right? The arrow syntax. And notice that we don't have a return, like return A times B, like we had here, right? In the arrow function, we have a return here. See that? So even here, it's unnecessary, right? We could get away with just removing the return and the curly brackets, and this would work just fine. But here we have an example, right, where here we have just remove the return and the curly brackets, and then we can just call the functions like we would always, right? Multiply 4, 5, and here embed it in the code snippet. So let's bring that in, implied return. So implied return. It works just the same, right? 4 times 5, is 20. Okay. All right. Let's take a very short break. We'll come back right after this, and we'll do some more labs. Okay. Don't go anywhere. Be right back. All right. Let's talk about introduce other types of other data types. Working with objects and with strings. Now, in particular, strings. Right. We're going to introduce a syntax, right, that's going to allow us to better work with them. Right. Be able to manipulate them. Create new strings. Right. and these are oftentimes referred to as template strings, where we provide a template, right, for a string, and then it allows us to embed expressions inside that can evaluate, right? Now this uses a different character for the string. And we have double quotes, we have single quotes, and now we have backticks, right? These backward single quotes, and this allows you to use quite several much better syntax, right, for working with strings, right? In particular, it allows you to have multiple lines, right, that they can spread across multiple lines, without having to add, the plus operator over and over and over, right? And also, instead of using the concatenation characters, plus and whatnot, to embed expressions, right? You can just embed them using this escape sequence of the $ curly bracket. Right, so let me show you. Let me let's create a little example of a template literal. Let's see. Let's add that. All right, and let's copy this. All right, so here we are declaring a just a couple of variables, right, and numeric variables, and illustrating different ways of concatenating content. So you can still use the regular plus operator that allows you to concatenate, a string with another string, or string with a Boolean, string with an integer and whatnot, right? And it will convert that other data type into a string, right? So that the whole thing becomes a string. Now, to achieve the same thing, you can use instead this backtick template little new syntax, right? That is a backward tick like that. See that? So it's not a single quote, right? And a single quote would create a constant text string like that. See that? Notice that this is literally that string here, but instead, backticks. What it does is that now this is a literal string, right? 2 space plus space 3 space equals space, and then this is an embedded expression, right? So where you evaluate whatever that is into a string, and it gets concatenated with the whole rest, right? And this allows you to do some very powerful things, and we're going to be using this new syntax quite often. You should only use it if you need the the powers of having to embed strings. If not, you should just stick to the regular single quote or double quotes, right? Here's another example of embedding the username. You can also embed expressions such as ternary expressions, right? As long as this inside expression evaluates to a string, then you can do whatever you want in here, right? So here we have, depending on logged in, we evaluate to yes or no. So logged in is yes or no, right? Depending on what it is. And then here we're just displaying the content. So let's include this in lab 3. So template littles. Let's see. So we have templates, template littles. And there it is. So we have 2 plus 3, 3, 2 plus 3, 5 twice, right? And then whether you're logged in or not. Okay. All right. So let's talk about another data structure that is, quite useful, right? In any programming language, the JavaScript arrays. Let's take a look at JavaScript arrays. So here's we have a simple array, right, of numbers, and so you use the square brackets, right, to declare arrays. Now, one cool thing about JavaScript, or dangerous, I guess, is that you can mix and match data types, right? They don't have to all be the same data type. Here we do have it all integers, and when we have that, you can use functions such as filters, map, find, all sorts of functions on that array, right, to compute either a single value or a different array, right? So this, for instance, filter takes an input array, right? And it calculates a brand new array, right? It calculates presumably a smaller array, right? So, for instance, all dot filter, it calculates, based on the original array, it's going to compute a new array. That what it does is that it can take as argument a function, right? A function here that the function can either evaluate to true or false. And what it does is that it iterates over the array, and for every item in the array, it calls the function that you give it here as an argument, right? And as it's iterating, it passes each item in the array to the function as an argument, as a parameter, and then the function either returns true or false, right, for that particular parameter, right? So for one here, we're doing 1 modulus 2. Is that equal to 0? No, right? So 1 modulus 2 is not equal to 0. So maybe it's not divisible by 2, right? So it returns false. So because it returns false, the filter is going to filter it out, right? It goes away. I don't want that number. For 2, and then you evaluate 2 modulus 2 is equal to 0. Yes, right? It is divisible by 2. So because it returns true, I'm going to keep that in the resulting array. As I go, basically I am filtering out all the odd numbers, right? I'm only keeping the even numbers. So that's why even is a brand new array. Nothing happens to the original array, right? Even is a brand new array that is a subset of the original array, right? That only includes the even numbers, 2, 4, 6, 8, and 10. Now, here's another one, right? We're using filter. Notice that in both cases, we're using the new arrow function, right? The new arrow syntax, right? That it's so much more compact, right? You don't have the function keyword, right? It just have 2 characters. But you can make it even more narrow, more compact, right? Here we have we have removed the return, we have removed the curly bracket, right? They're no longer there because the return is implied, right? Here, as I iterate 1, 2, 3, 4, I'm calling this function here, right? And it's saying, is this modulus 0, a modulus 2 or not, right? Notice that it says, is it not? Meaning it's filtering, it's looking for the odd numbers, 1, 3, 5, 7, which are not divisible by 2, are not divisible by 2. Right, so notice how much more compact this is here. Plus, the parameter parentheses, I've dropped that as well. So this is much more readable, very easy to read, as opposed to using the much more verbose legacy version, with the function keyword, the return, and all that, right? So yeah, so this is just one of many functions, right, that can be applied to arrays to either compute another version of the array, right, or right to to collate, right, all the values into a single value, and we'll see examples of that. Yeah, note the syntax here but they're pretty similar, right, with using the return and not. Okay. So here's another example, right, or discussion on whether we're using the newer syntax, right? That it's much more compact, right? With the arrow function, the equivalent syntax of using the older function syntax, right, where you use the function, right, and the parameter and the return. Notice how much more verbose and perhaps harder to read. It's much better with the new syntax. But you have to be careful, though, using the new syntax. If you are using this new syntax, notice that to debug this, there's no place for you to put a breakpoint, right? Because it will be just one single line. But sometimes you want to be able to step through this, right, and see the value of I as it's changing over time. And so we'll talk about debugging in a minute. But here, definitely, there's no way to put a breakpoint, right? So oftentimes you need to convert this into the more verbose version, right, where you have an explicit return, just so that you have an additional line where you can put a breakpoint, right? Now, if you do that, careful, right, because you do need the curly brackets, you need the return, you're closing curly brackets, right? And then if you want to put it back into its original to its original syntax, right? Where there is no return, there's no curly bracket. You have to remember to remove everything, right? Remove the return, remove the curly bracket. If you remove just the return but not the curly bracket, it's not the same, right? You need to remove everything, return and the curly brackets. All right, so just be careful. Another very popular function that computes arrays, right, based on input arrays is the map function, right? So map function allows you to iterate over the initial array, right, and compute a brand new array, right? That what it does is that for each item, right, it's going to pass it to a function argument here. It's going to pass it, and as it evaluates the function, each one of the values that it computes, right, they're going to be stored in a brand new array, right? So, for instance, with 1, right, the input is 1 times 1. You get 1. Here's the new array, 1. If we try with 2, there's 2. Then 2 times 2 is 4, and we're collating all these values into a brand new array, right? And we're assigning it to squares. So 3 times 3 is 9. 4 times 4 is 16. So the square array is going to be the same length as the original array, but the new values, right, based on the new data that was computed for every item, right? So map, right, it's a function that is going to be super, super important, right, to for us to compute user interfaces. Here's just a couple more functions. Find, it iterates over the array. These all take functions as arguments, but some of them, like filter, compute a new array, but some of them, like find and find index, don't compute an array. Actually, they come back with a single value, right? So find is checking to see, where is it that the input, 1, 2, 3, 4, 5, which one is greater than 3. And once this is true, for each one of them, when it finds the first one that makes this true, it stops iterating and it returns. This whole thing evaluates to, right, the value that made this true. So greater than 3, then that's 4, right? Because 1 is greater than 3, no. 3 is greater than 3, no. 4 is greater than 3, okay. So this whole thing evaluates to 4, right? Or instead of the value, you might be interested in the index. What position is this true? So then you would use find index, so that it evaluates, 1, is 1 greater than 3? No. 3 greater than 3? No. 4 greater than 3? Yes. So it found it in position 2, 0, 1, 2. So this value is greater than 3, right? So it values to 2. And filter we saw already, right? Filter, it goes through each one, computing a smaller array, right? That is a subset. So which one is greater than 3? Then it will be just 4 and 5. Okay. All right, so let's go through some exercises, just to practice some of this. Right, so let's create a simple array exercise. Let's create a file called simple arrays, and let's copy that in there like that. And then let's bring it into the index page. So the simple arrays, there it is. So a simple array, so let's take a look at what gets rendered. So let's look at the exercise. So here we're declaring a variable, a block scope, blah, blah, blah. And let's see, the simple arrays is displaying number array 1, which is this one. There it is, number array. No. Okay, there it is, declare right here. Declaring 1, 2, 3, 4, 5. Okay, and it's displaying it just to show you what, how by default, how React renders an array. Notice that what it does is that it just concatenates each one of the items, right? 1 concatenated with 2, concatenated with 3, concatenated with 4, and that's what it renders as an output. The concatenation of all the every single value, 1 through 5, right? Actually, that's important later on when we try to render a map. Remember, a map computes a new array, and then we're going to want to render that map. And basically what it does is it concatenates all the values into a single big component, right? And then it prints that out, right? Without the commas. That's important though. There's no commas in there. So let's see, string array 1, it's this one, right? You have string 1, string 2. And we're just displaying that, which is the concatenation of both string 1 and string 2. Very good. Then we have variable array 1, which is just combining a whole bunch of stuff. There's different data types. Some things are numbers, some of them are constants, some of them are arrays, strings, HTML array. So they're all being munched up into a single variable array that has different data types. And what it does is just concatenates all of it together. The numbers, the strings, right, and the arrays. Everything kind of has a single value and displays that, right? And then we have to-do lists. Notice that we have an array here of line items. So here's another example where you can you can embed, right, two languages together. The outer language is definitely a JavaScript-like language, right? And then inside we have an embedded HTML, then back to JavaScript, then back to HTML, then back to JavaScript, right? Which is great, right? And so here what we're doing is that we're embedding those line items that they're going to get concatenated. They're going to be concatenated, right, into just one li following the next. So if you surround those two line items with an OL, like an order list, notice that it renders just like you would expect, right? A list, either a bulleted list or a numeric list, okay, which is awesome. Okay, let's do another one here, just to illustrate arrays, index and lengths. And let's see, new file. Oops, oh, that's not what I meant to do. Let's grab the name first. And let's show that. And then let's go into lab 3. And this is array index and length. There you go. Yeah, so we can ask an array what the length is, either by saying dot length, right, of the array. So this one is 5 items, and also we can ask what to look for a particular element in the array using the index of, right? It will look for 3. It'll come back with its position, which is position 2, 0, 1, and 2. Okay. Okay, manipulating array. So we can once you declare an array and give it its initial set of elements or components, you can after the fact you can add more items or remove items. So let's take a look at how to do that. Let's import them in lab. So this is adding and removing. So adding and removing items from an array. Oops. See? Okay. So let's take a look at the code. So here we are declaring a simple array of integers, of strings, just like before, right? Of DOM elements, right? Line items. So you can use the push. You can use push, right, to add new items at the end. Become comma 6. This would become string 2 comma string 3. Or you can add an additional line item to the end of this. So it would be buy milk, feed the pets, and then walk the dogs. Right. So that's how you add items at the end of the array. Or you can also remove items from the array using the splice function. Splice the function takes as arguments a location, right? Which index do you want to remove, right? And then how many items do you want to remove? So remove one item starting at position 2, right? So let's see how that worked out. So here we have 1, 2, 3, 4, 5, and then we added 6, but then we removed at position 2, we removed 3, right? One item. So notice that 3 is not there. We added 6 at the end. There it is. right? But we remove 3 from the middle. And finally here, string array, right, at the position 1, so string 2 is removed, so you end up with just string 1 and string 3, right? And then we just display them here. In particular, to do array, it includes that the third item there of walk the dogs that we have added using the push function. Okay. Certainly, you can loop over content, obviously. So let me show you here. Loop. And so here we are iterating over the array. We're iterating over the array, for the length of the array. We're retrieving each one of these strings, right? And then we are pushing it, copying it basically onto the next array string or array 2, right? We're just doing some minor manipulation of the strings as we retrieve them, right? We convert them into uppercase, right? So that we can then, render both of them. And well, actually, here we're just displaying string array 2 that should be capitalized. So let's add the for loops here. So for loops, right, that displays the all caps string arrays. And map functions is going to be one of the more functions that we're going to be using quite a bit throughout the semester. As we iterate through complex data types, data structures. So let's take a look at this real quick. So here we have an array, right? We have a square that computes the probably being used to compute these squares using the map function, right? So notice it's a map, right? Takes as argument the function square applied on the array here. So it computes, 1, 4, 9, 16, 27, 36, blah, 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 right? All those values into the array, right? Into the squares array. Whereas this one is shooting the cubes, the cubes array. Once we have that, then this just renders the 2 arrays, right? So this just renders, whatever, 1, 1, 4, 9, 16, blah, blah, blah. Whereas these are the cubes, 1, 8, 27, blah, 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 right? But the more important one is so these are obviously maps applied on arrays to compute other arrays. But here we have a much more interesting use of the map function. And this is how we're going to be using it mostly throughout the semester, right? We're going to be embedded inside of a code snippet, right? We're going to iterate over an array. And as we're iterating over an array, right, each item is going to output, right, a DOM element, a code snippet, right, an HTML snippet, right, that is going to transform basically the data structure to-dos into an equivalent representation using HTML, right? In this case, we are grabbing all those to-do items of buy, mail, blah, 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 right? And we are embedding them instead of line items, right? And then we're rendering the whole thing, inline, right, inside of the code snippet, right? So map function, let me include this in here. So map function, there we go. And we have it, right, there we go. So we have the 2 build milk, right, and feed the pets. That's being generated dynamically, right, as we iterate over the array, right? And notice this whole thing is an expression. So this whole thing evaluates to an array that contains multiple line items. And those line items are all concatenated so that they render properly inside of the OL, okay? Yeah, so this is very, very common use of the map function on an array, and we're going to be using that quite a bit, right? So anyway, so we have find functions and filter functions. Take a look at those. Get your own and add them to the lab3 index. Let's talk about objects, right? So objects allows you to combine, create compound data types, right, that combine various data types, right? So you can combine, various properties that have, numbers and strings and booleans and arrays and nested objects, right? All, within a complex data type called objects, right? So here we have an example of declaring a house that has different properties. here's the declaration of the house constant that has a property bedroom, bathrooms, right? An address that breaks it up into more details, how many sub properties of streets, state, city, blah blah blah, and then you have owners, capturing how many people own this property, right? So let's create this and a new component for house, and let's declare the contents. Let's and then once we declare it, the data type, we can use the return to compute, right, to convert the data type, convert it into a user representation. So the way we're computing it is that we're going to display the bedrooms, we're going to display the bathrooms, right, and then we're going to use JSON stringify. So JSON stringify, right, that's a global object that is available to the JavaScript runtime inside of the browser that allows it to convert objects, right, little objects like this, right, into their string representation, right? So it stringifies, converts objects into strings, right? Plus, you can do some formatting, right? You can have your own format function, or a simple format saying, just add, if it's nested, add, 2 characters here, 2 characters, right, when it gets rendered on the screen. Okay, and so yeah, so let's include that in our lab3 index. So this will be house. There we go. And there we go. So we're displaying the bedrooms, the bathrooms, and the data, right? We are rendering its its formatted representation, visually, so you can visually parse it. Okay, again, using stringify. So yeah, so just JSON stringify is used for converting data types into their string representation. In particular, when applied to squares, right? It's interesting that it uses the full formatting of square brackets and commas, and if it needs it, it also adds strings and whatnot, right? So yeah, work on that. Here's another example of iterating over a data structure and converting it to an equivalent visual representation. So let's create a folder of to-dos just to illustrate how we can manipulate or convert data structures into their equivalent visual representation. So here we have a to-dos JSON file. So it contains data formatted using the JavaScript notation, right? Right. So here I'm just adding some spacing here so that we can more easily parse this with our visual cortex. There we go. So yeah, so there's an array of objects, right? And each object has 3 properties: title, status, and done, right? And so we're going to iterate over this and transform data structures into an equivalent user interface, right? So first of all, we'll create a to-do items. And to-do items is going to be using the, wait a minute, yep, to-do items. Oops. Let me copy that. It's going to use the arrow notation, and it's going to it's going to be our first example of passing a component arguments. There it is, right? We haven't yet ever passed a React component arguments. Right? Here we're passing a single argument to do, and notice it has an equal sign. That means that this is a default value, meaning that if I pass to do and it has no value, then it will default to whatever I have here. So it defaults to what? An object, right? So to do is expecting to be an object, right? And the object by default, if I don't pass anything, it will default to an object that has a done Boolean value, a title string, and a status string, right? Basically the same schema as this to-do JSON file, right? So the done Boolean, the status string, and the title string, right? And what does it do, right? It renders the title and it renders the status, right? That's all it does, right? Inside of a line item, see that? So probably this to-do item is meant to be embedded inside of a bigger UL, right? An unordered list or an ordered a and or an unordered list, right? Tongue twister, right? Yeah. So let's use this inside of the context of iterating over that array. Okay. So let's create a to-do list like this. And so let's see. So let's add a to-do list here, right? And then let's copy the content. All right. So notice that this is the first example, right? Of well, I mean, we have imported components before, right? Certainly that, but it's the first time that we are iterating over an array. So well, actually, this is the first time that we're importing a JSON data file that contains an array, a data structure. We're iterating over that array. We're mapping, meaning this is the whole thing is going to evaluate to another array, right? The input array is an array of objects, but we're going to convert it into an array of line items, right? This needs to be an array of line items, okay? Right, because that's what the UL is expecting, an array of line items. So here I'm iterating over the input array of to-dos. I'm mapping, and what do I do here? So for each item, I am returning, right, the to-do item. See that? So I'm evaluating to whatever the to-do item evaluates to. What does the to-do item evaluate to? To line item. See that? So this whole thing, right? One of these evaluates to a line item. Okay, and that line item takes is parameterized because it allows it's expecting me to pass a to-do object here, right? To-do object that has as value, it's passing each one of to-dos down to the component, right? It's passing it as a parameter, and then the component is receiving it here as a parameter, which it then uses to render the title and the status. See that? So notice that this is the attribute, like we've done, just like we have the class name attribute for the UL DOM element. Well, to do is a property, right? That I can pass it because I've declared it here. I'm expecting a to do parameter with a value, but if you don't pass it to me, that's fine, right? I'm going to default to something, but you are passing it to me, right? You're passing to do, and so this value to do is going to have as value. You're going to have first this object, then here you're going to have this object is going to be passed in to do, and then this object is going to be passed in. So this is going to evaluate to a line item that it has going to be the title of buy milk, and then the title of pick up the kids, and then the title of walk the dogs, and then you have a status of deferred, blah blah blah. Okay, all right. So yeah, so let's the to-do list. Let's include that. Let's include that in the lab 3. So to-do list like that, and there it is. So I notice that it renders. Oh, actually, much nicer than I thought, right? So the to-do item, notice that what it's doing, right? It's rendering as a line item, but the line item contains an input field of type checkbox. There it is. See that? Okay. That the default value, whether it's checked or not, right? It's taken by a Boolean that is either true or false. So it's going to check this. So you have this check mark here because only the first one is true. All the ones are false, right? Notice that the only one is done, whereas the other ones are not done, right? So that's why we see that only one is checked here. And then followed by the title and the status. So the title, right, and the status, right, in parentheses. Everybody good? All right. All right, so let's talk about spreaders. So spreaders are a new feature in ES6 that allows you to copy, right, content that exists in one array and copy it over into another array. Or also works with objects, right? If you have an object, right, that has some values, some properties, right, some values in those properties, you can spread or copy, right, that particular object onto a new object. So object 2 has some hard-coded values, D, E, and F, right? But here we are overriding it by spreading the content of another object at the beginning of the target object, right? And I can use object one multiple times here, and then you can use it here again, right? Where you are copying over A, B, and C onto the target, right? So some interesting questions you might want to consider. So for instance, here, right, we have array 1, 2, 3. The resulting R2, right, is going to be, right, concatenating 1, 2, 3 here, 1, 2, 3, and then concatenate, adding the 4, 5, 6 at the end, right? Now, array 1 doesn't have to be in the beginning. It could be at the end as well, or in the middle. It doesn't matter, right? And it'll appear in the order in which you add it, okay? Now, objects are a little bit different. Here in the arrays, the positions are well known because they're the indices, right? And they're all zero base, 0, 1, 2, and so on and so forth. They're very well understood, right? And then you have the values. So you have indices and you have values. Now, in objects, you don't have indices, but you have properties, right? You have properties, D, E, F. Those are properties. So whereas arrays, you have indices and their values, here you have properties and their values, okay? Now, the indices in arrays are unique. There's only one index 4 or index 0, right? Index 1, index 2. There's only one of those indices. But in an object, actually, we could fall into the problem of having properties that have the same name. Like, for instance, here we have D, E, and F, right? If I add object 1 at the beginning, then it's clear that there's no collisions of namings, right? You have 1A, 1B, and 1C in the target object 2, and then it follows by 1D, 1E, and 1F. No problems there. But here, notice that we do have a problem, right? Because notice that I'm copying over A, B, and C here, right? But then my target object also has another B, right? Then the question arises on, well, which one wins, right? You can't have both B's. You need uniqueness in your properties, just like you need uniqueness in your indices, right? So here you have the object 1, you have the A, B, and C, 1, 2, 3, but then you have a B4 here, right? So the question goes, well, which one wins? The old B or the new B? Well, the last one wins. This declaration of B is the last declaration of the property B, then it overtakes all the other ones. So no longer is B, 2, right? Because we have overwritten it over here. Okay, so we can try this out. Let's declare here the spreader, and let's copy that, and then let's bring it into lab 3. So the spreading. Yeah, there it is, right? So notice we are using JSON stringify to print out the resulting arrays. Notice that we're stringifying array 1, and we're printing it out right there. So here's the original array 1, 2, 3, no changes. But array 2 is actually array 1, which is 1, 2, 3, right? Concatenated with 4, 5, 6. Right? And there it is, 4, 5, 6. Okay. Same thing with objects. We print out object 1, which is A, B, and C, 1, 2, and 3, 1. Right? And then here we are concatenating object A, B, and C at the beginning of D, E, and F. And they all coexist. They're all in the same target object. We haven't lost any one of them, A, B, through C, all the way through F. But here, right, because we are copying something that already has a B and then is being overwritten, notice that the original B doesn't make it, right? So this is A1, B2, C3. Notice that B3 is gone. It's no longer there, okay? So spreader is very, very important. Another example of a new feature added to ES6 is destructing. Right? So destructing. So destructing is the opposite of constructing. Right? So this is not to be confused with destruction. Right? We're not destroying any content. Instead, it should be understood as we are extracting. We are extracting content. So let me explain. So in the older version, right? If you had an array or an object and you wanted to retrieve individual items from that array or object, right? You would use this notation of indexing, right? So you retrieve the 0th element and that's the element number 2. And then that's how you would initialize A and B. Okay, which is fine, right? This still works. Also, if you wanted to swap the values of A and B, right, you would need an extra variable, right, that allowed you to temporarily store one of the values, swap the values, and then recuperate the original value of the temporary variable, right? Well, with the new syntax is we don't need any of that, right? So, for instance, here, if you're given the same array, right, but it's a constant, you can use this new notation, right, where we use the square bracket syntax on the left side of the equal sign, right? We're always used to using the square brackets on the right-hand side of the equal sign, right? But here we're using the square brackets on the left side of the equal sign. And what this means is that if you use it on the right, you are constructing, right, a data structure. But on the left side, it means that you are destructing, not destroying, you're destructing, which also means that you are extracting, right? So here we are extracting, by position. Since A here is in the first position, it's extracting the number 1, and B, since it's the last one, is extracting value number 3, right? So, which is the equivalent of doing list sub 0 and list sub 2, yes? But this is so much more elegant, right? And less verbose. Also, swapping, right? Notice that you can take the input. You can have an array, right, that has a particular set of values, and you can just use them on the left side, right, to swap them, by name, right, by swapping the positions. Okay. Other examples, right, is that it also works with objects. Here you have a particular object called temp that has properties A, B, C, and D, right? Typically, you would use the syntax of the dot notation to extract items A and B, A and C or whatever, right? And then store them in some local variable or whatever, right? Well, this syntax is now much less verbose, right? Instead of needing these 2 lines of code, you can just extract or destruct the values by their name, right? Here it's by position. Here we are destructing because A, right, is in the 0th position, so it takes the 0th item, right? So the first position takes the first value. Here the last position takes the last value. So these names, A, B, could be anything, doesn't matter, right? Because they're being bound by the position that they have in the particular array. Whereas here the name does matter, right? Because the properties are the indices, right? And so dot A and dot C matter, right? Because those are the names of the properties that were used. So here A and C are these would have to be properties that actually exist inside of the target array, right? So this is extracting A, extracting C, so that A and C are 1, 2, 3, and 3, 4, 5. Okay. Now it also works, right? The destruct syntax also works when invoking functions, right? So, for instance, here if I have a function h, right, and I invoke it with an array, an object, sorry, with properties name and val, here it is. The arg is the value of arg is name bar val 42. So in here you can then extract individual properties using the normal dot notation, right? And here it's being used again to display, right? But now because we have this new syntax of destructing, right? Now we can do things such as call the h function But instead of doing extracting each item line by line, right? Okay, instead of doing that, we can use the destruct syntax right in the parameter list. Here it is, right? In the parameter list, see that? We have a destruct expression that is extracting from the parameter that's being passed. So we are passing this parameter like that. And so we're using destruct syntax, right, to map each property by their name, and then initializing those values by their name. So name gets bar and value gets 42, and then we're just displaying that. Right? Now, because because we're using names and not positions, right? If this were an array, which also works with arrays, arrays would be using indices, right? Their positions 0, 1, 2, 3, which are immutable. Whereas here, because we're doing it by name, right? The destruct syntax, right, works just as well if you swap the names, right? Because names, the ordering of the names don't matter, right? Only the actual name of the property matters, right? Whereas in the arrays is the opposite, right? The name of the variable doesn't matter, but the position matters, right? So here's an example of using the same notation of the of destructing, but oftentimes you might need to rename the properties, right? So for instance, these names and vals need to match the argument, the property that's being passed here, but inside of the function, you might need to have new names. So you can use the syntax of colon, right, to give them new local names, right, to be used inside of the body, right? Now, it also works with arrays. So here we have a destructor syntax, right, using the square brackets, right, in the receiving end of a parameter list. And so we're passing an array of an argument, right? And then by the position name, right, because it's at the beginning of the array, it's going to get the first element, right, of the array. And this one gets the last item of the array, right? And we just print out bar 42, right? Other pretty cool syntax that was added in ES6 is that if you create, so say you have these variables. Actually, let's make them let. If you have some variables x and y, and you want to create an object that whose properties, right, the properties have the same name as the variables that you're using to initialize. So notice here we're creating an object that has a property x, and I'm initializing it with a value of the same name of the property, right? And here I am declaring another property y, and I'm initializing it with a variable that has the same name as the property. So there is a shorthand for this, right? If the property name and the variable name have the same name, then you can collapse that into just x comma y. So this is understood as meaning that, okay? This, when this gets transpiled down to the low-level JavaScript, right? This gets expanded to that, right? But it's a nice syntax, right, to make the language so much more compact, right? So let's look at a couple of examples. Let's create a destructing component over here. Let's see, destructing, and let's copy that. And I think we have a couple more. There we go, like that. So let's take a look at this here. We are declaring an object person and that has a name and an age. And here we're using the destruct syntax, but to extract the name and the age, right, and declare new constants, name and age, that have the values of the properties of the same name in the object, right? So this one line is equivalent to these two lines, right, of declaring name and age constants, right, and then extracting each one of the properties from the source object, right? Now I can do the same thing with arrays, right? I can create an array with values, string values, right, and then use the destruct operator on the left side, right? And assign it to these to the target array, and so it will bind, right, to the first item in the array. It will bind it with the value of the first value in the original array, right? And the second 2, and the third 3, right? And it just prints it out. All right, so let me display that for the destructing sample. So this is destructing. There we go. And there it is. So we have John and 25 are the names and age that we extracted, right? That we destructed from the object, or here we're destructing from the array. 1, 2, 3, where first is 1, second is 2, and third is 3. Okay. All right. Yeah, let's take a look at using this syntax, but in the context of functions, right? So here we have let's create a function destructing. All right. Let's see. And let's copy that. All right. And let's see, destructing parameters. So, all right, so let me include this in the lab 3. So this is function destructing. So function destructing. There we go. Okay, so let's take a look at the implementation. Okay, so here we are declaring an arrow function called add, another one with sum, subtract, and difference. All right. So notice that the first implementation just uses just regular A and B, that you can pass it as arguments, right? And you're declaring each one individually with its own data type, right? And then you're evaluating to respond with the addition, which is fine, right? Exactly the way we normally implement it, or perhaps we might have used the function keyword, but here we're using the new arrow. Only pointing out that we are declaring the data types of A and B. Okay, so here's the way we call it, right? 1, 2, so 1 plus 2, this equals 3. All right. Okay. Now notice this other version of an arrow function, where the arrow function, the parameter, actually doesn't take 2 arguments, but instead it's taking 1 argument, and the single argument that it's expecting, it's an object, right? And that object, I'm presuming that those objects have property A of type number and B of type number. So there's also a requirement now in TypeScript, right? That again, when you have a parameter to a function, you need to declare the data type. What type is it? This here, what does it look like, right? What types are they? And you can use that with the colon here. Colon allows you to add the the schema or the declaration of the type of whatever that variable is, that parameter. Here we're doing the same thing. We're saying that this single parameter is of type an object that has properties A and B. Both of them are numbers. Okay. So when I call subtract, I'm going to pass it a single parameter. There's only one parameter that it's expecting, an object, again, of that has properties A and B. And those values are numbers. And indeed, that's what I'm doing, right? I'm passing one object of A and B, and they're both numbers. So what's happening here is that when it gets received here in the parameter list, it's using the destruct syntax, and it's binding these local variables to the source object that is being passed as an argument. And what we're doing is that we're just evaluating the subtraction, right? So we're illustrating 2 ways that you can pass arguments, right? And I'm introducing this new syntax because it's actually, this new syntax is required, right, for implementing screens or components that can be parameterized, right? So here's just the output, right? So let's take a look at another example where we are, implementing kind of like a library of, just a very simple arithmetic operations, right? So let's create I've called the library math, right, which implements some really, really simple arithmetic operations. And so this is good chance for us to discuss creating multiple functions inside of a instead of a file. So here, notice that we're declaring multiple functions. They're all using the older legacy syntax, but we could have used the new one. That's fine. It wouldn't change anything. Here you have add, subtract, multiply, and divide. They all return the appropriate calculation of the arithmetic. But what I am introducing here is that notice that they're all being exported. See that? They're all being exported. But I'm also creating an object, assigned to math that has properties add, and value. So this is the same thing as add, like that. Right? It's a property add whose value is this add here, right? But because we can, because the name of the property and the name of the value have the same name, I can collapse it into a single identifier. So same thing with subtract, multiply, and divide. So I'm creating kind of like a map, of name value pairs, like a hash table, and I'm exporting the math as the default. Exporting it as the default. Notice that none of the other ones are being exported as defaults. See that? They're all being exported as just normally, right? So export is going to allow, basically the keyword export needs that other files are going to be able to import, these functions, right? And here they're also going to be able to import the math constant here. I can export functions, but I can also export, constants, variables, whatever, right? Here we're exporting an object here, called math. Everybody good? Now here, none of these are defaults, right? But this is the only one default, and that is the syntax, right? Only one export can be the defaults, right? And we've been using defaults quite a bit, like over here, export default quite a bit, throughout the last couple of weeks, right? But we haven't really explained this. We know that export means that I can import, right? But what it means to export default, right? So if you export without the defaults, right? Whenever you import it, you have to use the destruct syntax, which we just learned about, right? Whereas if you export default, when you import it, you don't need to use the destruct, right? And we've seen examples of that. Notice that here, this function is being exported as default. And when we import it, right? Notice that we import it, none of them are being imported using the destruct syntax, right? They're just being imported normally, right? No curly brackets anywhere, right? But I want to illustrate this case where I'm exporting a whole bunch of functions. None of them are default, only one of them is default, right? So how would we use it? How would we import these, right? So let's take a look at that. All right, so let's create here a destructing imports. So here I can illustrate what I mean. So let's copy that. All right, so let's take a look at this. All right, so notice that here, we are importing from math. Can I put this in a new line? No, it wants to be in the same line. From math, right? Notice that math, is being exported as is. See that? The default. Because it's default, right, it doesn't need to be inside of a curly bracket. Whereas all the other ones, all these over here, they are being kind of like collected into an object, right? And then they're being exported like a single thing, right? That you then need to destruct, right, to be able to access each individual function that is being exported, all right? So this curly bracket is a destruct syntax, right? It's a destruct syntax working here because this whole thing gets collapsed into a single output or a single object, right, with these properties, and we are destructing them, right, to assign them to local constants. But math, because it's default, right, we don't need to use the curly bracket syntax, right, to destruct, right? So that's one way to import. The other way to import it is to use import star. So import star from math. So notice that both from math, right? But you can say, import star. What this does is that it just grabs all of these, everything in here, into a single object, right? And then locally I can name it into a local constant. So I'm grabbing everything that is in math, right? Everything. And locally, I am calling it Matematica, right? So Matematica is going to contain Matematica dot add, dot subtract, dot multiply, dot divide, dot math, right? It's going to be there, right? So here I'm creating a little table just so that we can take a look at all the different ways that we can import them using, using math, using individual ones, the functions, right, or even this new Matematica object, right? So in the body, we're going to copy this content here, right, and we're going to just paste it in there like that. Save that, right? And let's import this. Did we import this? No. Okay, let's import it. Destructing imports into our lab 3. So destructing imports like that. And there it is. So I'm just creating an array where we are showing that we can use individual. We can use math dot, right? The math, because that's a default export, right? We can use math dot add, math dot subtract, and so on and so forth, right? Or we can use Matematica, right? Dot add, right? So using the star imports, right? That I showed you earlier, right? Or you can use them directly, right? Because we imported these individually, right? Over here using the destruct. So either through math, individually, right, or using the star. And you'll see me use each one in different ways. We'll come back to why would you use one or the other, and discuss that a little later. Okay. All right. Yeah. So that concludes the labs for this assignment. We are going to continue discussing a few more. How to use React.js and JavaScript to dynamically configure the styling a little later. I do want to discuss the project, right? So let's talk about the project and the various options that you have for the project, right? So if you go into the assignments, right, and click on projects here, right, you'll come to this page, right? And this gives you links to take a look at the 2 options that you have for the project, right? So these are mutually exclusive. You do one or the other, and you can work on this with in a team of up to 5 members. But if you want to work alone, that's totally fine. We'll go a little bit more lenient on you if you are a one member team. But so I'm going to go over the requirements for both, right? So first of all, let's talk about the add quizzes. Right? So let's open that up, right? So this option, right, asks you to continue working on the on the Canvas project that you've been working as an assignment throughout the semester, right? So throughout the semester, we're gonna be working on implementing, login, the dashboard, be able to, retrieve all this information from a database, right, and rendering all this. And we're gonna be working on modules, homes. You're working on the assignments as part of the assignment. We'll work on the people, all right, a little later. And so all that will be completed fully, right, by the end of the semester. But on your own, right, we're asking you to implement this right here, quizzes. Right, so if you click on quizzes, this is only visible to me as a faculty. This is not visible to you, right? Well, actually, you can see the quizzes, but you can only take the quiz. You can't create quizzes. So, for instance, you can't add a quiz, right? So I'm going to illustrate. I'm going to create a quiz just to give you a sense of on what it is that you're being asked to implement. Right. So as a faculty, first of all, faculty, or as a student, you need to be able to implement both types of users from a student's point of view or faculty's point of view. So from both, either faculty or student, when you navigate to your dashboard, the courses that you see here are the ones that are related to you as a student or as a faculty, either because you're enrolled as a student and you are taking the course, or as a faculty because you're teaching it, right? So you don't see all the courses, you only see the ones that are related to you. Then when you click on it, navigate, the content here, right, is specific to that course, right? So if you look at the modules, these modules are for that particular course. If I navigate to a different course, you would see a different set of modules, and that we're going to be implementing, in this assignment number 3. We're going to get started, in this assignment 3, right? And so all that will be implemented fully by the end of the semester, connected to a database. All that's going to be working, right? Same thing for the assignments. You're going to do that on your own as part of the assignments, where you're going to be able to add assignments. You're going to learn how to do that. Add them, delete them, update them, blah, 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 doing all sorts of CRUD operations. And the intent is that, as you learn how to do this on your own for the assignments and we show you for the modules, you would be able to then extrapolate that skill set, right, to be able to also create quizzes, right? So if you're a student, you can't create quizzes, but if you are a faculty, you would be able to create new quizzes. And just like modules and assignments are different per course, these 2 quizzes would be different per course, right? So if I go to course A, I would see a different set of quizzes that if I go to course B, it would be a completely different set, okay? So let me illustrate how this works, right? So if I click, as a faculty, I'll be able to, add a quiz. I would go here, and I would be able to, just like an assignment, I can edit the quiz, and I'm going to call it fake quiz 1, 2, 3. All right, just to make sure that you don't take this quiz. It's just a dummy quiz, and you can you'll need to use a WYSIWYG editor, right? So that you have this nice and fancy formatting. Again, later for the project, right? Not now. And you can set when it's available, due date and blah blah blah, and the I've taken screenshots, right, and explained all this as part of the requirements. Now, for creating and editing a quiz, you only need to implement the names of the quiz, the description, the quiz type, assignment, group, these couple of checkboxes, and these due dates and and date pickers, right? Not the real one has quite a few things that you can edit, and I've removed most of them, right? So you just a few here, right? And then these date pickers, right? But anyway, so once you create it, you can go into questions, right? And then you can add questions, right? The new questions group is not required. Find questions is not required, but new questions is required. You can add new questions. And there's a whole bunch of types of questions that you can create. Right now, for this, you're only required to implement 3 types of quiz questions. One is multiple choice, true, false, and fill in the blank. Only those 3, right? But you're welcome to implement others, right? So let me illustrate how each one of these works, right? So you can name the question. So this is my multiple question 1. Right, and then you can type here your multiple choice question. You can say, how much is 2 plus 2? Right, so that's the question. And then down below, you can provide multiple answers. Right, now since it's a multiple choice question, there can only be one correct answer, and you can put here which one it is. You can say 3, 4, 5, and 2. Okay. And then you get to select, well, which one is the correct one. You can say this one or that one. Now, it doesn't need to be this fancy. This could be maybe this could be a radio button, right, instead of this fancy arrow. Also, the original one allows you to provide explanations on why this is wrong. Like if a student
when they're answering selects that one, you can add an explanation why that one is wrong, or this one you can provide why this one's correct. That's not required, right? In the requirements document, right? The multiple choice, it looks just like that, right? Possible answer. You don't have to edit why is this correct or why is this not correct. And I'm using here the arrow, but it doesn't have to be an arrow. It could be a checkbox or radio buttons. Okay. Also, you can remove the answer, and you can add any number of answers. So you can say, well, 12, add another one, 34. Right, so you can remove any one of these, right? So that you can remove maybe this one, right, and then remove it, and then you save it. Saved, and there it is. How much is 2 plus 2? Make sense? You can also add not a multiple choice, but a true false. So this is a true false one. You could say, is 2 plus 2 equal to 4? It's a question. It's true false. And then here you get to choose, well, which one is it? True, false, which is the correct answer, right? Pretty simple. Again, it's not required that you provide whether it's, why is it correct and why is it false? Why is it not correct, right? The particular choice. You say, update the question, right? And finally, another type of question, the fill in the blank question. So this is my fill in the blank one question. You can say, how much is 2 plus 2? Right? And then you put a blank for the student to put in the answer, right? And then here you can add any number of possible answers, right? So we can say one of the correct answers might be 4, right? Another one correct answers might be 4, written out in English, right? Or maybe different languages, right? Cuatro, right? And so these are all correct answers that the user could fill out that blank, right? And right, and so the way this is going to be rendered is that it's actually no, it's going to provide an input field right underneath for the user to fill out, right? And so you can add any number of answers. You can delete those answers, and you can update, right? And so this quiz, for instance, only has three questions, but you should be able to add any number of questions, right? And and then you can save it. You can save this. Once it's saved, right, you have this summary of what you have edited and how many points, right, in total. And as a faculty, I can preview the quiz, right, to see what would a student see, right? I can touch on that preview, and it would show me, right, all of them at once, right? Or you can configure this to display one at a time. Also, you can configure so that it randomizes the answers, right? The positioning of the answers that is not always the same, right? And then it allows you to answer the question, right? And put in the your answers. You can submit, and once you submit, right, it grades you. It says whether you were right or wrong. If you were wrong, so say you go and you do it again. Say you answer wrong, right? So right and wrong and whatever, right? It says submit. It grades you, says how much you got, what's your score, right? And it tells you what your answer was, but it highlights also the answer that would have been correct. If it's correct, it just highlights it as green, right? And in red what you answered and what the correct answer was. Okay, correct answers if there are several correct answers. Okay. Now, because I'm a faculty, this obviously doesn't not work towards my grade. I don't have a grade, right? Now, if I were a student, then this would work towards my grade, right? And I should be able to go to quizzes, right? Go into that quiz see my grade. I should be able to see, well, what grade did I get? When did I take it, and what grade I got, right? And I should be able to see, right? I should be able to take the quiz only once. Well, you can configure how many times. You can say, there are you have 3 chances to take this quiz, and and then you get to choose, well, which one is it, right, that you got, right? And which one is the final one, right? It could be that you get you do it the first time, you got 100, and you don't want to take it again, and that's it. That's what you have. But you need to store the very last time that the student took the quiz, right? So that they can come back here, right, to the quiz, and they can see the grade that they got, right? And they should be able to review, right? There should be a button that allows you to view the right answer. So this should give you the grade, right? And it should display down below, right? What you got wrong, right? It should have that history of the very last time that you took it, right? And what you answered, what you got wrong, blah blah blah, whatever. Okay. Yeah. And each student a separate answers for that quiz. So each student can go and see the same quiz, but they'll see their answers that they took. Okay. Anyway, so that's documented here. True false question, the fill in the blank question, a quiz preview, right? And that you need to persist the student quiz, the last quiz that each student took. Okay. Okay, so that's one of the options. The other option is to implement a social network around a topic of your choice. Okay, so you could choose maybe books or sports or stocks, right, or whatever you want to choose. Your food is very popular. Um, Events is very popular, and so have to be a social network, right? It could be anything that you need several types of users that want to collaborate, right? And so for instance, if it's sports, right, it could be that you have the fans, right? You have the players, right? The coaches. You have all different people that participate and want to collaborate, using your application, right? If it's a store, right, you have the seller, the buyer, the reviewer, right, the system administrator, right? And so for the quiz, right, certainly you need to have 2 types of users, right? The faculty and the student, right? And their user interface is different. Okay, I guess I can put the video here now. Right. So you can for the quizzes, definitely you have 2 types of users, definitely the faculty and the students. Whereas for here, yeah, you have to come up with your own types of users based on whatever theme you choose, right? But it is required that you have, I think, at least 3 types of users, right? If there's a store, you can have the buyer, the seller, and the system administrator. The system administrator is a very popular type of user that you would need to implement anyway. Also the anonymous user needs to be implemented, which is a separate type of user. Anonymous means I don't know who you are, right? You haven't identified yourself, but still, my application should work for you as well, right? So let's go through this, right? So say I'm someone who logs in, identifying myself. So that's a requirement. You need to be able to identify yourself or register as a new user, right? And that so I can create a community of users. And once I log in, I can go to my profile, and then in my profile, I should be able to see all the things that are personal to me. Some of them might be publicly available, which is fine. That I get, and you get to choose what that is. Maybe an avatar is a picture of the person is publicly available. Maybe the username is available, but maybe their birth date is not available, email, address, things like that, phone would be private details, information, right? Which only you that as logged in should be able to see it. Plus any information that you might have created that is related to you somehow. Any posts that I might have made, any movies that I might have reviewed, any songs that I might have liked, all the people that I'm following or following me that somehow I'm related to them. So anything that relates to me in my database, right, should be right summarized here in the profile, right? So when I log in, I have access to my profile. I can also have access to the home screen, right? So when the first thing that I see when I come in is the home screen, and the home screen should be tailored to me, right? There should be some information that when I come in, I know who you are. You've identified yourself. It should greet me with some information about me, right? For instance, it might be maybe the last person that recently followed me, or maybe the last post that I made, or something that is tailored to me. If it's searching for movies, maybe the latest movies, based on my preferences, right? Also, that I'm referring to as the logged in content. I know who you are, so I'm showing you some logged in content. Now, if you don't know who I am, then there should be some, whether you know me or not, there should be some section that is dynamic, right? And it's generic, meaning it's visible by both the the um, um, the anonymous user, so somebody who I don't know who you are, but it's also available to somebody who I know who you are, right? So this might be some generic content about the latest movies in the box office, the latest books in the New York Times, right? And this changes over time, right? Every time you come in, it should be a different content. So anonymous content, not geared to any one person. It's generic, but it's dynamic, changes every time, right? Plus logged in content, right? Content that is tailored to me because you know who I am, okay? Uh, Also, whether you're logged in or not, since whether anonymous or not anonymous, and I know who you are, I'm going to have a search screen, right? That is going to allow me to interact with some third-party API, right? So if it's a movie site that I'm interacting with, they'll have some API endpoints that I can send my request, my search request, and it'll, for instance, I might send a query about Batman, right? And the query goes out, maybe it's IMDb, and that API is going to respond with an array of movies or TV series or comic books, right? That match my search criteria, right? And I'm going to display that here in my search screen, right? And summarized either as a grid or as a table or as a list or however you want, right? Now, it should be a summary, right? Maybe just an image and the title. That's it, right? Now, if you click on any one of these summarized items, right, it should take you to another screen, right, called the details screen. Now, the details screen is also populated by the remote API, right? Now, typically when you retrieve objects from a remote server that you don't own, usually the objects will have a unique identifier for each one of the items that comes back. Now that ID you could use it right for subsequent queries that you can go out to the server, right, and say, oh, well, movie 123 or movie 345 or movie 758, right? And so you can go out to the remote API, comes back with much more details about that specific item. Again, whether it's a movie, a song, an album, right? Or recipe or stock or whatever. And then you're going to use that to populate a detail screen, right? With all the information that lives on that third-party API. Now, again, none of this information lives in your database, right? All this information lives in somebody else's database, right? You're just accessing, it's all read-only, right? And one of the things you need to find is, you should start now as soon as possible. Look for APIs that allow this kind of interaction. One is doing an open-ended query, right, that will return a summary of results with IDs of each item, and then subsequent queries that allow you to ask for, more information about individual items in your query. Okay. So this detail screen has two portions. First, the first portion is the information that you retrieve from the third-party API. Okay. Now, if you're logged in, I should be able to interact with this information that comes back. I should be able to, either read a like the movie, right, or hate the movie, or maybe write a review, right, or bookmark it, or whatever. I need to be able to interact with this information, right? Now, if I'm not logged in and I'm anonymous, I should still see the content from the third-party API, but I should not be able to interact with it. I shouldn't be able to like or create a post or review, right? Leave, 5 stars. I can't do that because I'm not logged in. Now, whether I'm logged in or not, right, irrespective, I should be able to see down below the interactions that have occurred between the community, of this application and this particular object, right? Now, all these interactions, people having left a like or a hate, or a review, that you need to store somewhere. You need to create the data, right, that relates user somehow to that particular item, right? So you're going to need to store that somewhere, and you need to store it in your own database. You can't store it in the remote database because you don't own that, right? That's owned by IMDb or Amazon or Google or Yelp. Other people own that data. You'll usually just have read-only access to that data. You won't have write access to that data, right? So you need to store it somewhere, and that will be in your own database. So in your own database, you will have to create in your own server. You'll need to create, web APIs that should allow you to like a movie or post a review to a movie, and you need to pass in, the IDs of these movies or these albums or these songs, right? And you'll need to create in your database entries saying that, Alice likes the Terminator, right? And Bob likes the Titanic movie, right? Typically, you'll need to add, several records, right? For instance, you'll need to represent the user as a record. You'll need to represent the movie or song or stock. You need to represent it also in a separate record, right? And also you need to represent the relationship, right? That so and so Alice, wrote a review. So that's the relationship, to that, on that book or that movie or that stock. Okay. So usually it'll entail creating, 3 different types of entries in your database, right? And creating the relationship. Okay. So again, so irrespective of whether I'm logged in or not, I should be able to see down below that Alice likes this movie, Bob wrote a review, and so I could see their username and what they wrote right here. And if I click on, again, this is whether I'm logged in or not, doesn't matter. If I click on the username, this should take me to their profile. Okay, so I'm now visiting someone else's profile. This is not my profile. Well, I mean, if I'm logged in or not, right, I should be able to see somebody else's profile. I should only be able to see my profile if I'm logged in. Obviously, if I'm not logged in, I can't see my profile because I'm not logged in. I don't know who you are, right? But right, if whether I'm logged in or not, in both cases, I should be able to see someone else's profile, right? And someone else's profile should include a mixture of things, right? It should include the public details, right? Maybe the username, maybe an image of the avatar of that person. Maybe that's it, right? You get to choose. You get to choose what is private and what's not. Certainly you should not show private information such as, email, phone numbers, right, addresses, or anything like that, right? But you choose. You get to choose that. But also down below, right, I should see all the information that is related to this person, to this one person. I should be able to see all the people that they are following, all the people that follow them. I should be able to see all the movies that they like, right? All the links to all the articles that they've written, right? And so, for instance, if I see that they like the movie, Aliens, I'll be able to click on that movie, right? And it should take me back to the details screen and show me that movie, right? And I can see, down below in the comments, I can see that, oh yeah, that's the article that they wrote. Oh yeah, I can see that they have 5-star ratings, right? And so that's so also if I see that if I'm looking at Alice's profile, I can see that Bob is following Alice. And so if I click on Bob, right, then I navigate to another profile. I navigate to Bob's profile. I can see that there's a relationship between Alice and Bob. Okay, um, and yeah, obviously only I can see my profile. The only difference between my profile and somebody else's profile is that in my profile, I can edit all the stuff that belongs to me, right? I should be able to remove a review that I posted. I should be able to edit a review. I should be able to, remove stuff, right? I should be able to view and edit my private information as well. Okay. Also notice that in the remote profile, the ID of the user is being used to display someone else's profile, whereas when I view my profile, notice that there is no ID being captured. So the identity of the person, right, of who's logged in and the profile that I'm displaying, the personal profile, all of that information is being kept at the server level using session and cookies and whatnot. And all that, we're going to learn how to do that, as part of the assignment. So by the time you get to the project, right, all that part of, logging in and identifying person, all that is for free. You'll get that for free, right? Also, roles and whatnot, and also that you'll be implementing for the assignment anyway. But as you get to learn how to do it for the assignment, make sure to start working on the project as soon as possible. And whenever you learn a skill for the assignments, I encourage you to get started and using those skills to also work on the project. It's never too soon to get started on the project. Okay. All right. There's a question on the chat about the quizzes project. We have to create students as well as teacher screens. So does it mean we have to make whole website from the perspective of the student? No. So I mean, you will be creating it, right? You will be creating different roles for faculty and students. So definitely, by the time you get to the final assignment, right? You will have implemented modules and homes and dashboard from both the point of view of the faculty and from the point of view of the students. Like for instance, if you're a faculty, I'll be able to create a module, but if I'm a student, I'm not going to be able to create a module. If I'm a faculty, I can delete a module. If you're a student, you cannot, right? As a faculty, I can create new courses, but as a student, you cannot, right? And you can't delete them. So all that of managing roles and showing things and not showing things depending on the roles of what can you do and what you'll be implementing all those things as you go through assignment 3, 4, 5, and so forth. So yes, when we're talking about the quizzes, that's also as well, right? As a faculty, I can create quizzes, but as a student, I cannot create quizzes. I can take the quiz, but I can't create a quiz. As a faculty, I can delete a quiz, but as a student, I cannot, right? But all those things you will have already practiced, for assignments, modules, and courses. Okay. The two project choices seems to be of different difficulty. The first one is something which we will be doing whole whole semester, and we just have to develop one. Well, so yes, that is true, in the sense that you'll have a lot of the styling all done. Now, for the open-ended um, um, website here, where you're implementing a community, you can also use of the same project, right? So you can just use the same project that we've been working here, right? Of creating Canvas, and you feel free to reuse all the everything that we've been working on. So, for instance, the login, right, and registration and profile, you can reuse all that, right? So this part, this part of logging in and registering and profile, right? That will have been created already for you. Obviously, you'll have to create the all the relationships, right? And those relationships are going to be similar to what you would be doing for the quizzes anyway, right? For the quizzes, I'm giving you the topic, which is quizzes. For the social network, you're choosing the topic, right? You're choosing the schema, you're choosing all those things, right? So in that sense, yes, it's a little more challenging because you get to choose what it is that you're building, and right, and but in both cases, you'll need to create data structures from scratch. You'll have to create tables and foreign keys and all that from scratch. Whether you're doing quizzes or you're doing the social network, that's all from scratch. And feel free to use the same code base that we have been using for Canvas. So you could, if you're creating a book or movies or something like that, expanded, and it'll be just an additional uh, link here, right? That would allow you to enter your project, right? If you want to, you could follow that social network and just add it to Canvas. So it would be, you could use Canvas as the topic, right, of education. Of maybe you can integrate it with YouTube, right, where you can search for online tutorials, right, for different topics, right, and you add them to the Canvas application. That would be totally fine. Yeah. So yeah, feel free to reuse the assignment as a basis, right, for your project. There's no need to start from scratch. Let's see. Maybe have already mentioned it, but just to clarify, will the grade be weighted based on the number of teammates? No. We used to do that where we would throttle and make it more things that you need to implement when you are a bigger team. But what we've found is that bigger teams doesn't mean that it gets easier. It actually gets harder. And for those that have done you've done software engineering. It's the added complexity is that you guys are going to need to merge each other's work and integrate all that, and so it actually becomes harder. I think that the ideal size for the teams is a team of 2 or 3 at most, and so I'm going to assume that in general, just 2 or 3 people are working per team, and that's fine. That's a great size. That if you decide to go 4 and 5, you're actually working against yourself. Unless you guys have worked together in other courses and are and know how to use Git very well, where you can merge each other's work and avoid conflicts when you're merging. It's actually not non-trivial. So that's actually a great experience to learn all about that.
but I'm not going to make it harder on you by asking you to do even harder stuff. Now, we are definitely going to be a little more lenient if you're doing this on your own, which is fine, right? Totally one person can do this. But yeah, no, we would definitely be a little more lenient on you if you're a one person team. All right, so let's take a very short break, and we come back. We're going to do office hours. Okay. All right, hold on. I'll be right back, and then we'll go office hours.